Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 13th, 2025. So, just yesterday, this paper introduces a multi-agent system that achieved first place among open-source projects on the prestigious GAIA leaderboard. The paper is titled, AWorld, Dynamic Multi-Agent System with Stable Maneuvering for Robust GAIA Problem Solving. And as we'll see, their approach significantly boosts both accuracy and stability. Essentially, the authors propose a novel architecture where one AI agent, which they call a guard agent, acts as a second pair of eyes to help another agent solve problems more reliably. Alright, moving to the results, these charts really break down the performance gains on the GAIA benchmark. The bar chart on the left shows accuracy using two key metrics: pass at 1, which is getting the answer right on the first try, and pass at 3, getting it within 3 attempts. Their multi-agent system clearly comes out on top. But what's really interesting is the chart on the right, which shows stability. Adding tools makes the single-agent system less predictable, but the multi-agent system reduces that variability, showing it's more reliable. Building on those results, this table shows the official GAIA test leaderboard, providing public validation for their system. You can see their AWorld agent right at the top, achieving first place among all open-source projects. It scored an impressive 81.73 on average, outperforming other strong contenders. The scores are also broken down by difficulty level, showing its robust performance across different challenges, which really solidifies its top ranking. So to understand the philosophy behind their system, the authors offer this helpful analogy from marine navigation. This chart shows a standard zigzag test for a ship. The blue line represents the rudder's angle, a direct control input making sharp, decisive changes. The orange line shows the vessel's actual heading, its smooth, responsive path. This visualizes their core idea. The guard agent acts like the rudder, providing targeted corrections to steer the problem-solving process, or the vessel heading, onto a stable and accurate course. This table then provides the formal mathematics behind that ship maneuvering analogy. It shows the linearized equations of motion, which are essentially a simplified mathematical model describing how a ship moves. The equations factor in the vessel's velocity and acceleration, forward, sideways, and turning, as well as its physical properties and external forces like wave drift. The point is that just as these well-defined physics principles govern a ship's trajectory, the guard agent provides a structured way to steer an AI's reasoning process. So this diagram shows the AWorld architecture that makes this all possible. The entire process is a dynamic loop. On the left, the execution agent works on a task, building up a complex context from prompts and tool responses. On the right, you have a set of tools it can use. And here's the key innovation. The guard agent is treated as one of these tools. The execution agent can send a verification request to the guard agent and get correction feedback, effectively getting a second opinion to stay on track. This table provides the detailed experimental results, comparing the base model, the single-agent system, and the multi-agent system. If we look at the average pass at 1 accuracy, the multi-agent system achieves a score of 67.89%, a nearly 9% improvement over the single-agent system. But the most crucial finding is in the last row, the standard deviation. The multi-agent system cuts this variability by over 17%, confirming it performs much more consistently and reliably. Alright, to wrap things up, the key insight here is that adding a guard agent for dynamic supervision makes these complex AI systems both more accurate and, more importantly, much more reliable. This agent as tool approach is a promising direction for building more trustworthy AI. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.